Hi, natural science students. Welcome back. Today you are going to be combining what you learned in our prior class in which we constructed a graph to represent our data for the change of state lab with ice changing to water and water changing to steam. And then we also had some informational session in which you had the opportunity to see what the science is behind molecules or atoms altering as an object changes its state. If you also remember, if we look at this portion of the lab, there was a portion of it where you made a prediction. If you did not make a prediction, you sort of need to put yourself in the place before we did the lab and circle one of these predictions now. And so if we could pause the video. And welcome back. So now that we have a prediction, we're going to check out what our graph says about what happened in the experiment, and we will answer some questions during the first half of class today. These questions need to be completed by the end of first half of class today in order for you to take a break, and the sub is going to collect your paper no matter whether you are finished or not. And so I want to make sure that your grade represents what you know and understand. So it's really important that I get a measurement of what you've learned from investigating changes of state of ice and water. So I'm going to scroll down here. You have your data and you use that to make a graph on this page. And now we are at the question section. And I'm going to talk through each of these questions so that you sort of understand what the expectations are. And your job by the end of the mod will be to have all these questions logically and accurately answered. So number one says, look at the data you collected in data table number one. You can also look at your graph. What happened to the temperature during the experiment? Tell us the time ranges in which the graph goes up, goes down, and stays the same. 3 sentences for this, one for each part of the graph. When you look at your graph should have 3 parts to it. And so here's an example of a sentence that you might type, and I'm going to go ahead and type one out here so that you can see what you would be expected to do. And so you would want to have a sentence for the first part of the graph, you'd want to have a sentence for the second part of the graph, and you would want to have a sentence for the third part of the graph. And so let's just check out the first one. So during the beginning of the experiment, the temperature, and this is the part of the sentence in which you tell us what the temperature does. You have 3 choices. Did it increase, did it decrease, or did it stay the same? Now for staying the same, it doesn't have to be perfectly the same every time. We're looking for the overall picture. So if it's mostly the same, even if there are little increases or little decreases, we would count that as staying the same. Increase, you would expect to see a dramatic increase. Decrease, you would expect to see a dramatic decrease. And then we want to be precise here as to approximately the times in which this is happening. So during the beginning, it said Goff, of the experiment, the temperature, you say what the temperature does, and then you would want to include between X minute and Y minute, during which range that would be. For this X minute, it should probably be times 0 because we're talking about the first part of the experiment. You need to do this for the first part, the middle part, and the last part of the graph, describing precisely what is happening in each of those locations. Question number 2, we're going to go back to your prediction and decide whether your prediction is right or wrong. And notice that it says in question number 2, was your prediction right or wrong? Which parts of your graph convince you of that? We're going to need to be doing some explaining here. And I just want to emphasize for you, it's okay to be wrong. What's not okay is to pretend like you're correct when you're not, or to pretend like you're incorrect when you are actually correct. Folks, science is all about honesty. If you want to get credit, you're honest with this question. I promise you that if your prediction is wrong, I'm not going to take off credit because you are wrong. I will take off credit if you are dishonest. So you need to let us know whether your prediction is right or wrong. You know, this is a good opportunity to mention that in science, we don't learn anything when we're right. We learn things when we're wrong, because when we're surprised, we know that there's something else going on here that we didn't know before. So I promise you that it is okay if you're wrong. You just want to be honest in evaluating your prediction. And just to go up here real quick, reminding your 3 predictions, what you would do is you'd read your prediction, and then you'd ask yourself, is that what happened for the whole experiment? And if it is not what happened, then you would say that your prediction was not correct. We would deny your prediction. Questions 3 and 4 are asking more about the science of what is happening during the changes of state in this experiment. We have two changes of state that are happening in this experiment. We have a solid turning into a liquid, and then we have a liquid turning into a gas. And in our prior class, we defined the scientific words for what each of those particular changes are called. So question number 3 is, which change of state is happening during the first flat part of your graph? I'm going to go ahead and highlight this, because that's what you're going to pay attention to here, the first flat part of your graph. Focus on that. You got to do some imagining here. Imagine back to the experiment. Imagine looking at that beaker. At the beginning of the experiment, what was happening to the stuff in that beaker? Was it melting, freezing, condensing, evaporating, sublimating, or depositing? And you also want to describe how that matches the definition. What did you see happening? So we have an example sentence here. This change of state is called, you pick one of these 6 words. I'll highlight them in pink, and then I'm going to highlight this blank in pink as well, so you know where you're going to be putting that word. And what happens in this change of state is, this is where you're going to describe what happens. Now, if you need help with questions 3 or 4, what you can do is look back to your notes from last time, because last time we defined all of these words. Now, question number 4 is just like question number 3, but notice what's different about it. Which change of state is happening during the second flat part of your graph? I'm going to highlight this in green because this is a little bit different. We have the same six choices. How does what happened match the definition? And then, so same 6 words. I'm telling you right now, it's going to be a different word though. So I'm going to highlight in a different color, and then that matches up with this blank right here. And what happens during that change of state, so we can connect it to the science. Questions 5 and 6 are thinking about how does energy move and what is energy doing? Remember what our big picture question was that we started this section with. Number 1, big picture question is, how does adding or removing energy change matter? And the first step that we have to do is think about the pathway that that energy takes, and the second step is to consider what that energy is doing. So question number 5, which pathway does energy take to make the change of state happen? You're going to put these words in the correct order from beginning to end. Beaker, hot plate, ice. There is only one correct answer for this question. And I'll give you a hint, where do we want the energy to end up in this experiment? And so what you're going to do is you're going to write a sentence that describes in what order energy moves through in this experiment, and how do you imagine that happening? Okay, beaker, hot plate, ice, those are your 3 words. You're going to put them in the correct order for how energy is moving in this experiment. Question number 6 is no doubt the most challenging question for this lab. You can do it. I'm going to help lead you through it. And in order to answer question 6, you need to think about what energy can do. And for our purposes here, I want you to think about energy as like money in the bank. Okay? You can deposit money in the bank, you can take money out of the bank, but in order for you to use that money on something, once you take that money out of the bank, like think of physical cash, you can only spend that physical cash in one place at one time to do one thing. So you take cash out of the bank, you have cash in your hand, you move that cash, or in this case, move this energy to a place where you want to do something with that cash, and you exchange it for goods and services. Okay, an example of a service, like you go to a restaurant and you order a delicious milkshake, and you hand the cash over in exchange for the milkshake. That cash can only do one thing in that particular moment. So question number 6 is asking, what is the energy making happen during the time that the temperature isn't rising? Okay, energy can only be spent on one thing at a time. There are 2 parts in this experiment in which the temperature isn't rising. But we know from our experience the hot plate was on the whole time. The hot plate is giving off energy the whole time. So what is that energy doing to the stuff that is in the beaker during those times in which the temperature doesn't rise? It's not being used to make the temperature go up, so what is it being used to make happen? Another way to rephrase this, and is shown in the question here, is energy can only be spent on one thing at a time. So if it isn't being spent to raise the temperature during the beginning and the end of the experiment, what change is it making happen inside the beaker during those flat parts? There's a flat part at the beginning part of the graph in which the temperature isn't increasing. What are we using that energy to make happen instead? There's a flat part at the end of the graph in which the temperature is not increasing. What are we using the energy to make happen instead? Okay, so these 6 questions are due by the end of this first half of class, and you're going to turn it into the sub, and I'm going to read over them, and there is a rubric on the back side of your paper if you want to check out what I'm going to be looking for. I'm going to be looking for accuracy, precision, and clarity here. Okay, because there are correct answers to these questions based upon the data that you see. Precision, in that I want you to be sure that you're being very precise in terms of evaluating your hypothesis and specifying the minutes in which things are happening for number 1. And I'm also going to be looking back at your graph for precision as well. And then, of course, clarity. You should shoot for complete sentences. I have to be able to read your writing. If there's some of you in the audience who, because of your IEP, can type things, I will allow you to type your answers on a separate sheet of paper, but then that needs to be emailed me before the end of this first half of class. Okay, so I wish everybody success on this activity. You're going to do great, and the expectation is that we will be silently working on answering all of these questions before the end of the mod if you would like to take a break.